Okay, so today we are going to learn how to determine horizontal and vertical asymptotes and graph rational functions. I've given you this handout that explains how to do it. We're going to use this handout. We're going to underline stuff on it and box things in so that we can highlight some areas that are important. Okay? And then on the back, there is an example problem that we are going to do together as a class. Okay? So we've only got about 17, 18 minutes before some of these students have to start leaving, so we need to kind of hurry. Okay? This one right here. You don't need that one yet. Okay, yes. You guys were all supposed to grab one earlier. Okay, now. Okay, how to find vertical asymptotes. Okay, vertical asymptotes occur where the function is undefined. I want you to underline that sentence.
Can I highlight it?
Yeah, or highlight it, one or the other. In other words, they occur where the denominator equals 0. So just find the domain. Where the domain doesn't exist, that is where the vertical asymptotes occur. So we did that problem. We did those problems for the bell work today. And it's kind of like the problem on here. I have 2 over x minus 3. Well, I want to know where the vertical asymptote of that one is. And it's at positive 3, because if I put 3 in for x, 3 minus 3 would make 0, which would make this function undefined because we cannot divide by 0. So you just take the bottom, you set it equal to 0, you solve that equation, that would be your vertical asymptote. So if you were to go to your graph, it would look like that. You would put a vertical asymptote right there. Remember, asymptotes are just kind of like imaginary barriers that the graph will get closer and closer to, but not cross. Okay? It will not touch them. So that is an example of finding vertical asymptote. Now, today I gave you a problem that was quadratic. Okay? Let's say I had something like 4x over x squared plus 6x plus 5. Let's say I asked you to find the vertical asymptotes of that one. That is correct. We can do this one by factoring. It's a quadratic equation. What 2 numbers can you times together and get 5, add together and get 6? Okay, and so we know 1 times 5 is 5, 1 plus 5 is 6. So we set each of those factors equal to 0, and we get -1 and -5. So at -1 and -5, -1 and -5 would be asymptotes, right? So it would look something like this. We would have a vertical asymptote right there at -1 and right there at -5, because the domain of this would be all real numbers except for -1, -5. Okay, thanks. Okay. Any questions on finding vertical asymptotes? Yeah. You guys, obviously when you start getting to be able to factor quadratic equations fast, you're going to be able to see that in your head and get those fast. It won't be a problem. But some of them are more complicated, so you have to work at them. Okay, so do we know how to find vertical asymptotes? Okay. Now, how to find horizontal asymptotes. And I got to tell you this, you guys, I think finding horizontal asymptotes is really, really easy. But every time I teach this, I get about half the students understand it really well, and the other half, they have no idea what's going on. And the only thing I can think of is they're not listening, because it's really not that hard. So listen. I'll make sure you get it if you listen. Okay? And we're going to do several examples with your shoulder partner, so you should be able to get those down. Okay. A function can have only one horizontal asymptote, one oblique asymptote, or neither. I want you to do this. I want you to underline one horizontal asymptote, one oblique, or neither. In other words, you guys, you will never have 2 horizontal asymptotes or more. You can only have 1. You can never have a horizontal and an oblique. By the way, oblique means slant. It means that it's going on an angle. No, we've talked about horizontal, which is this way, and vertical, which is this way. Oblique is a slant, or we sometimes call it a slant asymptote. Okay? You can't have both, a horizontal and an oblique. You can't, and by the way, you might not have either one of them. You might not have a horizontal or an oblique. Okay? You'll never have both. Now, you can have as many vertical asymptotes as the denominator is undefined. So if you have a linear polynomial in the denominator, you're going to have one vertical asymptote. If you're going to have a quadratic, you can have up to 2. If you have a cubic polynomial in the denominator, you can have up to 3. You can, it depends on the power inside. You can have a million vertical asymptotes. Not likely you're going to see something like that, but you can have a lot of vertical asymptotes. What we're going to do is, most of the ones we're going to do are going to have 3 vertical asymptotes or less. Okay? So we're going to work with those. But you can have a lot of vertical asymptotes, but you can only have one horizontal or one oblique. Okay? And you might not have either one of them. And before we go today, I'll show you a function that has no asymptotes, vertical, horizontal, or oblique. It will not have a single asymptote. Okay? No, it won't be linear. It will still be rational. I'll show you. You can probably figure one out. When I get through teaching you, I'll see if you guys can figure one out first, based on what we've learned. Okay? No, x plus 5 is a linear equation, so it's not a rational equation. So, okay, so to find out which kind, if any, it has, you have to compare the degree of the numerator with the degree of the denominator. I want everybody to underline that. Compare the degree of the numerator with the degree of the denominator. Now, I think most of you guys know what a polynomial is. Polynomial. Okay, for example, we have 0 degree. We're going to write down the degree of these. You have 0 degree, 1 degree, 2 degree, 3 degree, 4 degree, and so on. Okay, polynomials. An example of a 0 degree polynomial would be 2, a constant. Okay, an example of a 1 degree would be something like 3x plus 4, because x is to the 1 power. Okay, an example of a 2 degree would be a quadratic, like x squared plus 2x. An example of a cubic would be something like 5x cubed minus 6x squared plus 2x minus 1. That would be a cubic. Okay? No, let me show you this. Let me see if I had x to the 0 power. X to the 0 power is 1. 2 times 1 is 2, right? So anytime you see a constant up there, since x to the 0 power is 1, we don't write x to the 0, but it could be x to the 0, right? So it's a 0 degree polynomial. Okay? So 3x plus 4 would be a linear because you have x to the first power. X squared is a second degree. And 5x cubed is a third degree, and so forth, right? So that's that. Now, a rational function is made up of a polynomial divided by a polynomial. So if I have something like f of x equals 2x plus 5, which is of degree what? 1. Or I have x squared plus 10x plus 24. That right there is second degree. So the top is 1 degree, right? The numerator is 1 degree. The bottom is second degree. You always look at the highest degree term. So we have 1 degree over second degree. Now let's read the 4 possibilities. There are 4 possibilities. Number 1, if the degree of the numerator is less than the degree of the denominator, then it is said to be a proper fraction, and there is a horizontal asymptote at y equals 0. Check this one out. Is the degree of the numerator less than the degree of the denominator? Yeah. You have 1 and 2. 1 is less than 2. So we're going to have a horizontal asymptote at y equals 0. Where is y equals 0? The x-axis. In other words, here's the x and y axis. Y equals 0 is a horizontal asymptote that is contains the x-axis. I would write that down on your paper, that y equals 0 is the x-axis. Because some of you guys forget that sometimes. If you think about it in terms of slope-intercept form, y equals mx plus b, if you think about the slope being 0 and the y-intercept being 0, you get y equals 0. If it has a slope 0, then it's a horizontal line. If it has y-intercept 0, it crosses the y-axis at 0. And so that's why it's that line right there. Okay? So if the degree of the numerator is less than the degree of the denominator, it has a horizontal asymptote at y equals 0. Okay, I'm going to give you a minute too. Does this one have vertical asymptotes, and if so, where? When you know the answer, raise your hand. Okay, yeah, we have a horizontal at y equals 0 because what's the degree of the numerator, you guys? 1. What's the degree of the denominator? 2. Is 1 less than 2? Then it's always at y equals 0. It doesn't even matter how much less it is. You can have you can have a 0 degree on top and a 4 degree on the bottom. As long as the top is less than the bottom, it's always going to be a horizontal at y equals 0. It will always do that. Okay, now we're going to go to number 2. Number 2 reads on here, if the degree of the numerator is equal to the degree of the denominator. Okay, I want you to put boxes around degree of numerator and degree of denominator. If the degree of the numerator, I already underlined, is equal to. If the degree of the numerator is equal to the degree of the denominator, then it has a horizontal asymptote at y equals a over b, where a and b are the coefficients of the leading terms of the numerator and denominator. I say leading terms, but it's the highest degree terms. Let me give you an example. Well, let's look at the example on here. Y equals 6x plus 4 over 2x minus 5. What is the degree of the numerator right here? 1. Okay, because this is 6x to the 1 power. What's the degree of the denominator? 1. Are they the same? Yes, they have equal degrees. So I am going to take the coefficient of the highest degree term in the top and the coefficient of the highest degree term in the bottom, and I'm going to divide them. So that would be the coefficient of 6x to the first is 6. The coefficient of 2x to the first is 2. I divide those and I get 3. So y equals 3 would be a horizontal asymptote. That means if I graph this, there would be a horizontal asymptote right here at y equals 3. Okay? And it doesn't even matter what comes after those. The 4 and the negative 5, they mean nothing as far as the asymptote goes. Got it? Okay, now I'm going to give you a couple of problems that I want you guys to tell me where the horizontal asymptote is. And I want you to discuss these in your groups. And then we will talk about them. Here's the first one, number 1. Okay, you guys talk about it in your groups. Okay, I'm going to give you a second to discuss those.
That's what I was thinking.
Okay, top one. Number one, what'd you guys get? Okay, there is a horizontal at y equals 0. Bottom one, what'd you get? How many of you guys got 1/5 at the bottom? Yeah, because this one, the degree of the numerator and the denominator are 3, and you take 1 divided by 5. So y equals 1/5. That's barely above the x-axis, right? Parallel to the x-axis. Any questions there? Okay, now, the next, you guys, I got to teach you about slant asymptotes because you're going to have a couple on the homework assignment. Okay, so we're going to add that on here. And you might see it when you're doing others. So the next one is if the degree of the numerator is exactly one more than the degree of the denominator, then it has an oblique asymptote. Exactly one more. Okay? To find the equation of this asymptote, you must divide the denominator into the numerator using long division. The equation would be the answer to the division problem without the remainder. So, give an example right here. F of x equals x squared plus 4x minus 2 over x minus 3. By the way, does this have a vertical asymptote? No. Does it have a vertical? No. Has a vertical. Where's the vertical? 3. Okay. Does it have a horizontal? Yes. No. It has an oblique. If the degree of the numerator, what's the degree of the numerator here? 2. What's the degree of the denominator? 1. If the degree of the numerator is exactly one more than the degree of the denominator,
Then it doesn't have 1.
then it has an oblique asymptote. It will not have a horizontal asymptote. Do we understand that? It will not have a horizontal asymptote if it has an oblique asymptote.
So what does it mean when it says divide?
Okay, this is what it means. X minus 3 divided into x squared plus 4x minus 2. Long division. How many of you guys remember how to do this? Okay, listen carefully, because I don't think most of you guys remember how to do this. It's been a little while since we've done it. Okay, so you want to ask yourself, what do I times x by to get x squared? X. So you put the x, I always like to line it up above its like term. Okay, and then I multiply x by x minus 3. What do you get when you times x by x minus 3? X squared minus 3x, right? You got to distribute the x to both terms. Okay. Then I subtract. Remember how I taught you to subtract? Change the signs of both terms. So I change that to a negative, that to a plus. That adds up to 0. That adds up to 7x. Hey, technically, you guys, we don't really, the only thing we have left to do is say, what do I times x by to get 7x? 7. So when you put a plus 7 here, you don't have to go any further than that because we don't care what the remainder is. Okay? Because our equation of our oblique asymptote is the answer without the remainder. Y equals x plus 7 is the oblique asymptote. That means if you graph this right here, okay? Okay, so in other words, my oblique asymptote, it would have a y-intercept of x, of 7, and then it would go on a slant like that. And if you had if you also have a horizontal or a vertical asymptote about right here at 3. I'm guessing this graph, you guys, I don't know which way it goes. I don't know if it's between this part and this part or the left and right part, but let's say it's the left and right part. It would look something like this. You guys can graph it in your calculator to see, but that's what it would look like. Something like that. Or it might be this blue part right here. It might be in here and between there. Someone graph it in your calculator. By the way, when you put this in your calculator, what do you have to put? How do you have to put in? Parentheses around the numerator and the denominator. Okay? It doesn't even matter which mode. It's not a sine, cosine, or tangent. Okay, so check that out and see if that's where you might have to change your window to see the whole graph. But that's what it would look like. Okay, do we have that? It's the blue one? Okay, so it's the blue part. Any questions on that? It's probably good to look at this on your graph. Actually, it's the green part. Yeah, if you put in the line, if you just want to see, if you put in the line x plus 7 as well, since it's your asymptote, graph that in there. Holy cow, I think you put something wrong in here. X squared minus, oh, you put a minus instead of plus. Yeah, it's the blue part. It's the blue part, you guys, on here. Well, okay. So it doesn't show the blue part? You need to get a new calculator. All right. Here we go. Last part. Number 4. If the degree of the numerator is more than 1 more than the denominator, then it has no horizontal or oblique asymptotes. Underline the no part. Put a box around no. If the degree, and underline is more than 1 more than. For example, if you had this function right here, all right, say I had this. What is the degree of the numerator here? 3. What is the degree of the denominator? If the degree of the numerator is more than 1 more than the degree of the denominator, then it has no horizontal oblique. Is this true right here? Okay, 3 is 2 more than 1, right? So this one has no horizontal or oblique. The only thing it could have is vertical. It doesn't have vertical. At -2. 2 times -2 is -4. -4 plus 4 is 0. So at x equals -2 is a vertical, but it has no horizontal or oblique. Okay, everybody, turn your page over. We're going to do one graph. This is how you are going to do your assignment today. So pay attention carefully. We're going to follow. I've given you 6 steps, even though it has 5 twice. You can cross that second 5 out and put 6. 6 steps. Okay? We will analyze and graph the function f of x equals x minus 1 over x squared minus 4 using the following steps. So we have f of x equals x minus 1 over x squared minus 4. Okay, step 1. Determine the domain and draw the vertical asymptotes on the graph. Okay, I'm going to give you 30 seconds in your group. Discuss where the vertical asymptotes are going to be. Go. Where are they going to be? How many of you guys got 2 and -2? Okay. Look, you guys. Most of you guys got this down, but some of you need to set the denominator equal to 0 if you can't see it right off, and solve the equation. I can set x squared minus 4 equal to 0, add 4 to both sides, and I get x squared equals 4. And then take the square root of both sides. And I get x equals plus or minus 2. Because 2 squared would be 4, and negative 2 squared could be 4, right? There's 2 answers. So, well, the domain would be all real numbers except 2 and negative 2. Because 2 and negative 2 make it undefined, right? Okay, so the domain would be all real numbers except for 2. Yeah. Okay, so I color in my 2 asymptotes. Go ahead and do that. Step 2. Locate the x-intercepts by setting the numerator equal to 0 and solving. Mark them on the graph. Locate the x-intercepts by setting the numerator equal to 0 and solving. So what is the numerator right here? X minus 1 is the numerator. What do I get when I solve that equation? So go to 1 on the x-axis and mark the x-intercept. So you guys, to get an x-intercept on a rational equation, what do you set equal to 0? The numerator, okay? That's where the x-intercept will be. Keep that in mind. You guys, this is why I'm giving you these steps so you can refer back to it when you start doing the assignment. And when you also do the test. Except for you need to have it memorized by the time you get the test, or have it on your 3x5 card by then, okay? If you do the assignments and everything right, you'll probably have it by then. Okay, step 3, locate the y-intercept by putting 0 in for x. So if I put 0 in for x, I'm going to get 0 minus 1 on the top, and 0 squared minus 4 on the bottom, which is going to give me negative 1 over negative 4, which is equal to? 1/4. So on 1/4 on the y-axis, which is about right here, is going to be your y-intercept. Okay. Go to step 4. Locate any horizontal or oblique asymptote by using the method learned earlier. Does this have a horizontal or an oblique asymptote?
0.
What do you guys think? Okay, I've heard 0. Why is it 0, Kai?
Because the bottom is higher, the degree is higher than the top.
Okay, the degree of the bottom is higher than the degree of the top. Remember, when the degree of the top is less than the degree of the bottom, there is a horizontal at y equals 0. So right here, at y equals 0, now, someone asked me an obvious question when we got to this point at last time. Okay, Sarah, go ahead. Ask that really loud so everybody can hear it. State it as a question where everybody can hear it.
It doesn't touch the
Thank you, Sarah. / Kayla. Nah. So, Kayla, go ahead and say that again.
Okay, if it can't touch the asymptote, then why is there x?
That's a good question. Okay. You guys, this will never happen with vertical asymptotes, but with horizontal asymptotes, sometimes a graph will cross in the middle of it. But as it gets out to its far reaches to the right and left, it will get closer and closer to it, but never touch it. So in this case, it actually crosses the horizontal asymptote in the middle part. It does that on horizontal asymptotes. Okay? It can do that on horizontal asymptotes because it doesn't make it. Horizontal asymptote doesn't undefine a function, right? Like a vertical asymptote does. But you'll never find one crossing a vertical asymptote. But sometimes in the middle, you'll see it crossing. When we graph this, you'll see that this gets closer and closer to this as it goes out to the right, but it'll never cross it out there, even though it crosses it in the middle. Okay?
It's like asymptote is equal to asymptote. It's crossed.
Well, no, it is because for large numbers of x, it will get closer to it. Yeah. You'll see when we graph it.
This is the definition of an asymptote.
No, that would be Mr. Cahoon's definition. And Mr. Cahoon's definitions is not always precise. Well, that is true, you guys. It's true for Please listen. It is true for vertical asymptotes, but it won't always be true for horizontal. But for large values, it will be true, not for close-in values. Okay? It crosses. It actually crosses. If you put in 1, if you put x, 1 in for x, you would get 0. Okay? Yeah, there are going to be 3 parts to it. You'll see it. Every time you add a vertical asymptote, it creates more and more parts to the function. Okay? All right, let's go to step 5. Graph f of x on your calculator. So I want everybody to graph this into your calculator now. And I already graphed it into my calculator. Make sure you put parentheses around the numerator. Put parentheses around the denominator. Hit zoom 6 if you want the same window as I have. Okay, when you graph it in there, you put x minus 1 in parentheses divided by x squared minus 4 in parentheses. You hit graph, or zoom 6 if you want a standard window like mine. And that's what it's going to look like. So what we're going to do now is we are going to trace our graph in there. We're going to start right down here. It goes down here, it comes up, crosses right there, and then comes up and gets closer and closer to that line there. Okay, then on the right side, it does this. And on the left side, it does this. So draw that all in there. Now, you'll notice, you guys will notice that on the 2 vertical asymptotes, these lines that are going up and down forever get closer and closer to them, but don't touch them. You'll notice on the horizontal asymptotes that as you go out far and wide, it gets closer and closer to them, but never touches it. But in the middle, it crosses it. Okay? Could an x-intercept be 5,000? Yeah. But not on this graph because it gets closer and closer to it as it goes out that way. But who just left? Where'd he go? Oh. Did he get his assignment before he left? Okay, you guys, this is problem number 1 on the assignment. Asking you to identify the vertical asymptotes, x-intercepts, and the horizontal asymptotes. So, how many of you guys set the denominator equal to 0? I heard at least one group. This group over here realized that they could factor a 3 out of that. If you factor a 3 out of that, what do you have?
X squared plus x minus 6.
Okay, so 3 times x squared plus x minus 6 equals 0. Now, since we're solving this equation, if you divided both sides by 3, what would happen to 3? It'd be gone, right? So it comes down to solving that quadratic equation. Does that factor?
Yes.
What 2? 3 and 2, both positive?
Negative 2 and 3.
Okay. Yeah, that factors be x plus 3x minus 2. So this is x equals negative 3 and x equals positive 2. Okay? And so that's where my vertical asymptotes are going to occur, at negative 3 and positive 2. Okay? Since you guys, the numerator is 1 and you're finding the x-intercept, you set the numerator equal to 0, right? Well, there's no variable to solve for, right? Is that a true statement? No. So therefore, there is no x-intercept. This is not going to cross the x-axis. This equation won't. And what is the y-intercept? What is the horizontal asymptote? Yeah, the degree of the numerator is 0, the degree of the denominator is 2. So there is a horizontal at y equals 0. By the way, the reason this one won't have any vertical asymptote, or horizontal, or x-intercepts, I'm sorry, is because, well, let's see, it has a negative 3 and 2. So there's going to be an asymptote there and there. I don't know why I put something along here. Shouldn't be one there. But I'm guessing this graph does something like this. Or the symmetric version of that over the x-axis. It's going to look something like that. Because to find the x-intercept, you set the numerator equal to 0. And if you set 1 equal to 0, that's not a true statement. There's no variable to solve for, so there is no x-intercept. Well, it finds the x-intercept. Remember, to find any x-intercept, you put 0 in for y, right? So basically, the function is 0 if the numerator is 0, right? Yeah, on a rational function. All the ones we've done before have been like polynomial functions or square root functions or like that when we were looking for the x-intercept. Okay, but with a rational function, the only time it's 0 is if the numerator is 0. Because if the denominator is 0, it's undefined, right? If the numerator is 0, the function's 0. So what we do is we set the numerator equal to 0 and solve for that to find the x-intercept. Okay? All right, you guys, this assignment is doing 2 times. By the way, there are a few on here that have slant asymptotes. I will do one of those with you right now. Which one would you like me to do? Nothing yet. You want me to do number 3? Well, 3, you guys. 3 has, okay, we'll do 3. We'll find the slant asymptote of that. Okay, number 3. So we're going to divide negative 3x squared minus 3x plus 18 into x cubed minus x squared minus 18. Can we factor some? Yeah, you know what? Look at this one out here. Could we factor out a negative 3?
Yes.
If I factor out a negative 3, what would that leave me with? X squared plus x minus 6. That's the one we just did, isn't it? You know what? Let me think about this for a second. That's a good question. I believe that you should be able to, because,
Well, it's going to end up being x.
yeah, you know what? I believe you can, because if you look at the whole function right there, if you factor out negative 3 on the bottom, it would just mean that the whole function's being times by negative 1/3. So I don't think that would change the asymptote. Let's try it both ways. Let's do it this way first. Okay? And then we'll do it the other way. So what do we times negative 3x squared by to get x cubed?
X.
We times it by actually negative 1/3 x, right?
Well, this is really hard. Yeah, it's too hard. Let's just skip.
By the way, minus 18. I'm going to put 0x right here, you guys. Plus 0x minus 18. Is that what it was? Is minus 18?
Yes.
Okay. So I'm going to do this. We're going to, so it's going to be a negative 1/3 x that we're going to times it. Negative 1/3 x times negative 3x squared
X cubed.
is going to be x cubed. Negative 1/3 x times negative 3 is going to be
It's going to be x squared.
x squared. Negative 1/3 x times 0x is 0x. Negative 1/3 x times 18 is
6x.
negative 6x, right? No. Sorry, I shouldn't have done that. Negative 6x. Okay, so I'm going to change the signs and add. So that's negative, negative, positive. That adds up to negative 2x squared plus 6x. Bring down the negative 18. This is the last time we have to divide. Now, what do I times negative 3x squared by to get negative 2x squared? By 2/3 x. That's right. No, 2/3. Just 2/3. Ryan.
Yeah, where'd that come from?
Well, you know what? When I was writing it down, I was writing it. I looked up the top one. So let's go back to that. And x cubed minus x squared minus 6x. So guess what? That adds up to 0 right there, doesn't it? So that's just 0, and it doesn't really matter anyway. So what do I times negative 3x squared by to get negative 2x squared again?
1/3 x.
2/3. Just 2/3. 2/3 times negative 3x squared is going to give you negative 2x squared. So 2/3. So this is all I need. So y equals negative 1/3 x plus 2/3 is the equation of my slant asymptote.
So it's not the same when you factor it out. When you factor
Yeah, when you factor it out, it wouldn't be the same, would it? Okay, so it's going to be different.